Welcome to Pomodoro Joe for Friday, June 30th, 2023. Today we're doing LeetCode problem 1970, last day where you can still cross. This is a hard problem. So there's a one-based, interesting, this is one-based. There's a one-based binary matrix where 0 represents land and 1 represents water. You are given integers row and column representing the number of rows and columns in the matrix, respectively. Initially on day 0, the entire matrix is land. However, each day a new cell becomes flooded with water. You are given a one-based 2D array, cells, where cells index I is equal to row and column. Represents that on the ith day, the cell on the rth row and the cth column, one-based coordinates, will be covered with water. You want to find the last day that it is possible to walk from the top to the bottom by only walking on land cells. You can start from any cell in the top row and end at any cell in the bottom row. You can only travel in the 4 cardinal directions, that is left, right, up, and down. Return the last day where it is possible to walk from the top to the bottom by only walking on land cells. All right, and then we have an example here. So we have a bunch of land. On 1-1, we fill in 1-1 with water. On day 2, we have 2-1. Oh, interesting. So there 2 is the row and 1 is the column. So this is opposite that I'm used to. I'm used to like X and Y. So this is 2-1 fills in here, 1-2 fills in here, and that means we're blocked from going up to down. All right. We have another example, 1-1 and then 1-2. All right. And then a more complex example. Oh, and this is an interesting case we have to keep track of. So in this case, you can have diagonal water that blocks you from progressing because you cannot travel diagonally. All right, so that's something we have to be aware of. And then we have some constraints. All right, so we'll put 25 minutes on our Pomodoro timer and we will get started. So for this one, we have to think about what is the end condition. The end condition is when we cannot go from the top to the bottom. And how does that happen? Well, there has to be some water that basically blocks our path. How does the water block our path? So it looks like essentially there is a continuous body of water that occupies every single column. All right, that makes sense. If you had disparate bodies of water, like separate bodies of water, like this one, they might occupy all the columns, but you can still get past. But as soon as you fill in this square here, now you have connected bodies of water that occupy all of the columns. Okay, so we have to consider the bodies of water connected if they are even diagonally adjacent. All right, so I think for this, we will keep track of which cells get turned into water. When cells are adjacent to each other, we will merge them into one body of water. All right, and then when we find one body of water that occupies every single column, that means we've reached the end. You cannot traverse from the top to the bottom anymore by just going on land cells because we have some body of water that takes up every single column. Okay, so that's our strategy. Now, how do we merge these bodies of water? And for that, I think I'll use my new favorite algorithm, and that is the union find. So the union find will essentially let me create sets of separate bodies of water, but then when we have some piece of water or some square that gets filled in with water, we can now union these two bodies together into one body of water. So that's how this one works. All right, so let's do that. So this will be a variation on the union find algorithm. If you're not familiar with that, I'll try to leave a link in the description. You can also watch my other videos on union find, and you can look it up. The union find is new for me, so I'm probably going to butcher this, but I really like it. So let's see if we can make it work. All right, so we'll start with some result, set it to 0, and we will return our result at the end. All right, so since we're using a union find, let's actually define our two functions, union and find. So let's see, we'll define find first. So for find, we'll take in some cell, and this will return the group that it's in, or the body of water that it's in. So essentially how this will work is every body of water will be defined by some group label. And in this case, that group label will probably just be some cell, so some coordinates. I don't really know. Typically you'll have either a greater than label or a less than label. In this case, it's a little bit different because this will be a coordinate that has both an X and a Y, or a row and a column. So I think I'll just have a label, which is a row and a column. So the label for our group will be some coordinate. We find our cell by looking for this coordinate. We need to look up which group it's in. So for this, I'm actually going to keep a dictionary. This is going to be a little bit different than I'm used to. So let's see how this works. So I will have a group or a cell to group mapping. That's what I'll do. So I'll have a cell to group map, and that will be a dictionary. And let's put a little label here to tell us what it is. So the key will be a cell. I kind of want to say X and Y, but it looks like this is row and column. So it'll be row and column, and the value will be the group label. And that's also going to be a row and column. All right, so we initially have no cells in our cell to group map. When we do a find cell, all right, so we look up our cell in our cell to group map. So if cell is in our cell to group map, so we'll return the cell to group map value at this cell. So this will be holding our group. All right, if the cell is not currently in our cell to group map, basically we don't know which group the cell belongs to, then we'll make the cell belong to its own group. It's just going to be basically the label for itself. So the cell to group map for the cell will just equal this cell. That's pretty simple. Cool. So that's our find. Oh, I guess we still need to return it here. So we'll just return cell. All right, what's our union? So now our union will take two cells, cell 1 and cell 2. And what this needs to do is basically union the two sets, or the two groups that these cells belong to. So let's first look up which group these cells belong to. So I'll have group 1. Well, we have a function for this, so we can do find cell 1. And group 2 will be find cell 2. Let's just copy and paste. Cool. Now if these two groups are the same, then we don't need to do anything. So let's check for that first. We're just done and we can return. Cool. If they're not the same, typically you would have to find the greater or lesser groups, do some swap. For me, I'm going to do this super simply. If these are not the same group, I'm just going to force group 2 or cell 2 to be in group 1, and then we'll go through and find all of the other cells in group 2 and force those cells to be in group 1 as well. This isn't the most efficient, but I think it should work. So at this point, we know the two groups are not the same, so I'm going to force cell 2 and all of the other cells in that group to be in group 1. So for that, we'll grab this. So cell 2 will now be in group 1. All right. And now we need to recurse. Now we need to union our cell 1. We could also do group 1 if we wanted, but we can union our cell 1 and force our group 2. Now remember, the group labels are just cells, so we're forcing group 2 into cell 1's group. All right, and eventually those will converge on one group. Okay, so we have our union and we have our find. Now we need to go through all of our different cells, so every day in our cell list here, and add these cells to our groups so we can find which cells belong in which bodies of water. So for every cell in our cells, well, let's see. For every cell in our cells look like these are lists. Now, one thing that won't work here for me is a list because I'm using tuples. And the reason I'm using tuples is because one of them has to be the key into the dictionary, and you cannot use a list as a key. So I might need to turn this thing into a tuple. So let me call this chords. Oh, maybe I'll call it cell. And I'll call chords, and that will be a tuple of this cell. Not cores, chords, coordinates. That'll be a tuple for this cell. All right. Next, I need to look at all the adjacent cells. That's not just up, down, left, and right, but we also have to look at these diagonals to see if there's any water there. If there are, we need to union those groups. Oh man, that's a big one. So let's see. We have some offsets here. I'm just going to have a list of offsets, and these are going to be up, down, left, right, and then up, left, up, right, down, left, down, right. So these are a set of, it looks like that'll be 3, 6, 8 different options. All right, this is -1, -1, because we're going from here. This is our center. We're going -1, -1. So for this, we're using their screen coordinates where the upper left is 0, 0. So this is row, actually, I guess technically it's row 1 because this is one index. So this is row 1, this one's row 2, this is row 3. This is column 1, column 2, column 3. So for here, we're going down by one row and down by one column. If we're in the center, we'll be going 0 in our X or in our column direction. I guess that's the row, isn't it? Oh, this is confusing. We're going 0 in the row direction, so that will be this guy, but 1 in the column direction, or -1 in the column direction. Ooh, man, I'm confusing myself here. Oh well, I'm just going to do this based on the numbers instead of trying to think about it too hard. So this will be 1, and this will be -1. Right, and then I'm just going to space these out. So we're going to have -1s for all of this row. This will be 0. Let me give a nice space here. This one is technically 0, 0, so we don't really need this one, so I'm just going to skip this middle one. Let's see, this is +1, comma 0. I'll be respacing these to make a little bit more readable. No, this should be a 0. This should be A1 and A1. All right, let's space these out so they're a little bit more aligned. Okay, so I think this should do it. So -1, -1, 0, -1, +1. So basically we have a -1 column, a 0 column, and a +1 column. Same thing here, we have a -1 row, a 0 row, and a +1 row. So these are all the offsets. So these are the different cells around our current cell we need to be checking. So let me grab my X and Y out of my current cell. I guess this should be row and column. Let's do this right. All right, so that's our coordinates here. Then for every offset in our offsets, now we'll be using these offsets to create basically new cells that we need to look at to see if we have to merge these different groups or union these groups. All right, so let's see, I'll have C for our new cell, and that will just be equal to, all right, our current row plus O at index 0, and our current column plus row at, offset at index 1. Now we need to check to see if we have exceeded our bounds. All right, so if this current cell, this new cell at index 0, if this is less than 1, then we're out of bounds because this is a one based array. or if our column at, I shouldn't call this C. That's bad. Yeah. I should call this new cell, or adjacent cell, neighbor. How about that? There we go. So our neighbor. So if the neighbor at index 0 is less than 1, then we're out of bounds. All right? If our neighbor at index 1 is less than 0, then we're out of bounds. Our neighbor at index 0 is greater than, this would be rows, I believe, or neighbor at index 1 is greater than columns. In any of those cases, we are out of bounds and we can't count this, or we can't try to merge this, so we'll continue. All right. If we made it this far, then it's possible that this neighbor is also water, and if it is also water, then we want to merge these groups or union these groups. So first, let's just check if it's water. If neighbor is in one of our groups, so if there is an entry for this neighbor in our cell to group map, then this is water. If it's not in there, then this one isn't water and we don't need to worry about it. So if this is water, what do? We need to union them. So we'll union our neighbor Actually, let's do it the other way around. Let's union our neighbor. So we'll union our neighbor with our current coordinates. So that takes care of our union. Now there's a couple things that we're missing here. We don't have an initial way to enter our cells into our union find our dictionary here. So basically we're going through, we're never going to find anything in the dictionary because we've never put anything in the dictionary. So one way to get around that here, essentially once we have these chords, we know that this is water. We can just create an entry in our dictionary right here. And one way to do that, a simple way to do that, is just use our find. So we'll just find our chords. Now this is kind of a hack because we're not really using the find to find it. We're mostly just using it for this case here where we're creating an entry in our map. All right, so we're going to find our coordinates. That creates an entry in our map. Then we'll go through, we'll look at all the adjacent cells. If there are adjacent cells that are water, we'll merge or union their two groups. Now the final piece of this, we're not actually checking to see if we've reached the end. How do we know when we've reached the end? Well, as we discussed at the beginning, we know we are at the end when we have one body of water that actually has an entry for every single column in our grid. Okay, so we need to have some way to check to see if this has a column or an entry for every column in the grid. So let's create a function for this. All right, we've added our neighbor, we've unioned their two bodies of water. So if we're done, so is complete, then we can return, what do we return? Oh, this is another thing we're missing. We're supposed to return what turn or what day we're on. Now we're not keeping track of days in here, so we need to do that here. So for every day, and we will enumerate our cells. So the enumerate will return the index and the value at this index. So the day will be the index, the cell will be the value at that index. So we'll return the day that we're on. Now is complete. Let's see, we could go through all of our groups checking, but it would be better if we knew which group we just updated. So we only have to check is complete on the updated group. So for this, we'll just pass in the coordinates. All right, so now we need to create this is complete function. All right, so one way to do this is to go through and find out every single cell that's in the same group. So we could do a find on this cell and then go through all of the other cells in our cell to group map to find out if they're in this group. Check their column to see if it's already, I guess we'd have to keep track of the columns. So we need a set of columns. I have a better idea. How about this? Let's keep track as we're adding our different cells into these different groups. Let's keep track of all the columns that are in that group. So we need a new thing here. So we have a group column set. This is a group to column map, I guess. So for this one, the key will be the group, and the value will be a set of columns. So that makes this one pretty easy. So all we have to do is look up this coordinate. We have to get the group for this coordinate. So first we'll get the group. That equals find coordinate. And then we need to look up that group in this column map here. So the columns for this group will be the grouped column map for this group. And then we can just return the length of this columns group, if that is equal to the number of columns in our grid. All right, so this will tell us if we've completed our body of water, or the body of water contains every single column in our grid. If it does, then we are done. Okay, now we still need to update this somewhere. This is a little bit ugly. So every time we add some cell, well, let's see, how does this work? This will actually work with our union. Every time we union, we'll actually need to take the union of the two groups of these columns. Oh man, we have 2 minutes left. All right, this is going to get ugly. I apologize in advance. Every time we union, we'll have group 1, group 2. If they're all the same, that's all fine. Otherwise, if they're not the same, we'll need to grab, let's see, column set for group 1. Let's call this group 1 columns. I guess since we're merging group 2 into group 1, let's grab group 2's columns. All right, so we'll grab group 2's columns, and then we'll union them with group 1's columns and reassign that to group 1's columns. Oh, this is so ugly. All right, and the group 1 column map, that's just going to be the group 1 column map, union, this is a set operation. We'll union that with this group 2 columns. Okay, so now we've unioned those together. Now we might not want to do this every single time. Oh, we are out of time. Ah, shoot. All right, we don't want to do this every single time. We only want to do this basically the first time we come in here. We'll union those groups and then we don't need to worry about it, but that does mean that we'll have to like reset this one. So we'll have to check to see if this is even in the group. All right, so first we'll have to say if we have an entry for group 2 in this column map that's not empty, then we'll grab that entry, we'll union it with group 1's entry, replace group 1's entry, and then we actually want to set groups 2 entry to either a set or to none. I think we'll just set it to none. That'll make it easier. That means when we come in here, it'll be none and we won't do this a second time. All right, that takes care of this. Now we don't have an initial set to begin with, so we'll actually have to create a set up here. All right, so when we create this cell, then we need to create a column map for this cell. And that will just be a set, and that set actually needs to contain this cell's column. So that's this cell at index 1. And we have to wrap it in a list because a set requires an iterable. Oh man, that is super ugly. Okay, well, we are out of time, so let's just run this and see if it works. And we got something wrong. Got something not defined. Group 2 columns. That's right. There we go. Try this. And that works. Holy smokes. All right, we'll submit this, see if we can pass all the tests. We got something wrong. None type object has no attribute union, so that means this group 1 is missing the set. Let's see, we're creating the group set here, but we might be setting it to none here. All right, so let's see, we need to make sure that we actually have a set for group 1. How do we know that we have a set for group 1? We could just make this an empty set. Let's do that. It's not my favorite solution, but let's see if that works. All right, so this gives us a wrong answer. Let's use this test case and let's see if we can figure this one out. So I think one thing we want to do, let's switch this back to none. Down here, I am doing neighbor first and then coordinates. I think I might want to do coordinates and then neighbor. Now, this just means that the coordinates will be the thing that we're merging into, and we know that we've just created the coordinates here, so this should always have a set. So that might fix this problem. Now, this does make this really fragile, so this is probably not the best answer for this problem. Okay, so that works, but it might just be lucky. Oh, and we pass. All right, so we pass, and we actually do pretty well. We beat 89% for runtime and 59% for memory, so that's not bad at all. Now, I will say this is fragile. It does depend on the ordering here, which is not really great. We definitely wanted to do coordinates first because up in our union, we were always merging into group 1, so we wanted to pass in this coordinate as our first as our first argument, because we know we just created this coordinate, which means we know it has a set. All right, pretty fragile, not great code, but I don't have a lot of time today, and that's about all I got. So check this one out. This one again is LeetCode 1970, last day where you can still cross. For this, I used a union find. I really like the union find algorithm, but there's probably a better way to do this. Anyway, hope you enjoyed this, hope you had fun, hope you learned something, hope you can go out and write better code.